Science with Folly.
Kia ora, welcome to Science with Folly. Today we're learning about polarity. Now polarity is due to differences in electronegativity between atoms. So what is electronegativity? Electronegativity is to do with how strongly atoms attract electrons to them. And when we look at the periodic table, elements become more electronegative in this direction, with helium being the most electronegative. So let's look at polar bonds. Polar covalent bonds form when two different elements are bonded together. Let's have a look at this bond here between carbon and fluorine. Now, looking at the periodic table, we would see that fluorine has a higher electronegativity than carbon, and therefore we say that this bond is polar. And we use these symbols, a delta negative and a delta positive, or a little arrow with a plus down one end, to show which end is more electronegative than the other. However, when two identical elements are bonded together, the covalent bond is non-polar. In this example, two chlorine atoms bonded together. Because they both have the same electronegativity, there is no bond dipole and the bond is non-polar. Now let's apply our understanding of polar bonds to whole molecules. Firstly, symmetrical molecules cancel the effect of bond dipoles and are non-polar. So remember, symmetrical, non-polar, whereas asymmetrical molecules do not cancel out the bond dipoles and they are polar. So asymmetrical, polar. Here's an example, methane, CH4. It's got 4 C to H bonds, and each of those bonds is polar because carbon is more electronegative than hydrogen. But the molecule is symmetrical, therefore the bond dipoles cancel each other out and the molecule is non-polar. Here's another example, chloromethane. We've got 4 polar bonds, 3 of them are C to H, 1 is C to Cl, but this molecule is asymmetrical. Therefore, the bond dipoles do not cancel out and the whole molecule is polar. You can see that this end is more electronegative than this end. Finally, let's have a look at a molecule you should be all familiar with, H2o, water. Here's a Lewis diagram of it. And looking at it, you might think it's linear, but it's not, remember. It's actually bent because it is based on a tetrahedral shape. And if we look at it drawn like this, we can see that the O to H bonds are polar, so it has 2 polar bonds. This end is more electronegative than this end, and so the whole water molecule is polar. It's asymmetrical, it's got polar bonds, the molecule is polar. So here's 4 different molecules. Which ones are polar, which ones are non-polar? Think about it for a second. Polar, non-polar, this one's symmetrical. Non-polar, this one's symmetrical. This one, polar. I hope you understand this stuff. If not, watch the video again, do some revision, and you'll do well. Ka kite anō, see you soon.
Science with Folly. Science with Folly. Science with Folly.